Hello everyone, welcome to our next lecture, Creating Flight Plans with Mapping Apps. Once a drone survey project is properly planned, the next step is to create a flight plan that will guide the drone during the mission. Instead of manually controlling the drone throughout the survey, professionals typically use drone mapping applications to automate the entire flight. These apps allow the drone to follow a pre-programmed path, ensuring consistent coverage, proper image overlap, and accurate data collection. Let's walk through how flight planning works using mapping applications. Step 1. Open the mapping application. Drone survey missions are usually planned using specialized mapping apps that connect directly to the drone. These applications display a satellite map of the survey area, allowing you to design the mission visually. Once the app is open, you can locate your survey site on the map and begin defining the mission area. Step 2. Define the survey area. The next step is to draw the boundaries of the survey area on the map. Most mapping apps allow you to outline the area by simply tapping or clicking around the site to create a polygon. The software then calculates the total coverage area and prepares a suitable flight pattern. Defining the survey boundary ensures that the drone captures images only within the required area, making the mission more efficient. Step 3. Set the flight altitude. Altitude is one of the most important parameters when planning a survey mission. Flying at a higher altitude allows the drone to cover a larger area, but it reduces the level of detail in the images. Flying lower increases image detail but requires more flight lines and more time to cover the area. The mapping app usually calculates the ground sampling distance (GSD) automatically based on the altitude you select. Step 4. Configuring image overlap. Next, you will set the front overlap and side overlap between images. Overlap ensures that each image shares enough visual information with neighboring images so that photogrammetry software can stitch them together accurately. Typical survey missions use around 70 to 80% front overlap and 60 to 70% side overlap. These settings help produce reliable and detailed maps. Step 5. Review the automatic flight path. After the parameters are set, the mapping app automatically generates a grid-based flight path over the survey area. This grid pattern ensures that the drone systematically covers the entire site while capturing overlapping images. The app also estimates flight time, number of images, and battery requirements. Step 6. Check camera and capture settings. Before launching the mission, confirm that the camera settings are optimized for mapping. This may include settings such as shutter speed, image format, and capture interval. Proper camera settings ensure that the images are sharp and suitable for processing. Step 7. Upload and start the mission. Once everything is configured, the flight plan is uploaded to the drone. During the mission, the drone automatically follows the programmed route, capturing images at precise intervals. The pilot still monitors the flight to ensure safe operation and proper data capture. Using mapping apps greatly simplifies drone surveying by automating complex flight patterns and ensuring consistent, high quality data collection. In the next lecture, we'll explore another important aspect of survey planning: setting altitude, image overlap, and ground resolution for accurate drone mapping results. Thank you and see you in the next lecture.